Times live webinar, Beyond LLMs, the Power and Pitfalls of Multi-Agent AI. I'm your host, Dave Rubenstein, Editor-in-Chief of SD Times. And before we get started, I have a couple of brief announcements. First, today's program will be followed by a live Q&A. To submit questions, simply type your question into the chat at any point during the presentation, and we'll answer them afterward and get to as many as time will allow. Secondly, today's webinar is being recorded and will be available on demand on the sdtimes.com website under the SD Times Live tab at the top of the page. Okay, so now on to today's topic. Multi-agent AI involves the agents collaborating to solve complex problems, each with specialized roles, knowledge, and capabilities. Unlike single-agent AI systems, multi-agent systems enable distributed problem solving where agents can communicate, negotiate, and coordinate to achieve shared or individual goals. However, there are some issues that have to be addressed, such as latency through over-communication between the agents and the constraints on the network, just to name a few. So with us today to discuss this in greater detail are Abhishek Gupta. He's the principal engineer and head of data science at software development company Talentica, and Seema Menon, co-founder and CEO of digital marketing company Maestro.AI. And now to get us started, here's Abhishek.
Thanks, David. First of all, let me thank everyone for joining this webinar. Let me take also the opportunity to introduce myself. I am Abhishek Gupta. I'm heading data science team in Talentica. I've been associated with Talentica for about 5 years, and during this period, I have taken more than 15 problems to production, which covers almost all the areas of machine learning, whether it is a recommendation system, whether it is predictive analytics, text mining, or GenAI, and even image processing. With that, let's get started with the multi-agent AI webinar. Okay, a quick overview of the agenda. We'll first talk about what are LLMs and their limitations, why we require agents, and then we'll also talk about the need for multi-agents and what are multi-agents. Then Seema from Maestro.ai will cover one of the case study where they use multi-agents in their product. And then finally, I'll conclude by talking about some of the production challenges and what are our predictions for 2025 for multi-agents. Before going into the multi-agent details, let me talk about that. What's the state of art in GenAI? How the adoption is going around in the everywhere. There is a study by TechTarget which compares how the adoption increased from 2023 to 2024, which involved a survey from 800 companies. And overall, the observation is that the adoption increased from almost a 4% to 9% in different stages of the product maturity. Even in Talentica, about 50% of our customers have adopted GenAI at different stages, whether it's POC or pure production ready or being in live. So we did about 76 of the POCs, out of which 30 are production ready and 14 are actually into the production. So that's how the GenAI adoption is growing, and it will continue to grow in subsequent years. So let's take a quick poll, and you'll get a pop-up where a simple question is being asked, like what the challenges you have faced with LLMs. We'll pause for about 30 seconds so that you get time to take this poll. Okay, continuing with the multi-agent discussion, let me also quickly recap LLMs. LLMs are nothing but long context next token predictions, where tokens could be coming from text, or they can be tokens from image or audio or any other models. Um, there are different flavors of LLMs. Like one is managed LLMs, another is open source LLMs. Usually, managed LLMs are large parameter models, somewhere in 200 billion parameters, and open source models are roughly in the range of 70 billion. Some of the managed LLMs are GPT-4o, Gemini, Claude series, and some of the open source models are Llama 3, Quen 2.5, and even recent buzz on DeepSeek, the DeepSeek R1 model. Let's consider an example where we use LLMs in our doc QA example, where we have a set of documents and a user wants to ask queries related to the documents. So the way we use LLM is like first we take these documents, get the embeddings from these documents, and store it into the vector store. Now, whenever a user query comes, it goes to the LLM, which gets the data from the vector store and then output. For example, if we have a case where we have all the Talentica documents and we ask a query, what does Talentica do? So it will be able to get the relevant documents from the vector store and answer that. We'll take this as an example and see how it gets evolved over the subsequent slides when we talk about agents and multi-agents. With this simple example, it will be able to answer most of your queries, but again, LLM has certain limitations. LLM is limited by the data on which it is trained. So anything which is outside of this data, it will not be able to answer. In that sense, it's a bit static and doesn't cater, adjust itself to the real-time data. It has low reasoning capabilities, and it also hallucinates. Now, let me give an example of hallucination. Let's say, again, in the case of Talentica, if I ask a question, who's CTO of Talentica? And if none of these documents are talking about the CTO, then it will not be able to answer and it will try to fit some other name. So that's where we mean by hallucination. Because of these limitations, there is a need for a different wrapper of over LLMs, which will be able to mitigate these limitations. And that's where the agents come into play. So what are agents? Agents are constitute four components. A memory, which is nothing but chat history or feedback, which provides a relevant context to LLM. We have tools. Tools gives the capability of getting real-time data, the data which is not present in the LLM. It has that capability, and it also provides the capability to interact with internal databases. With these tools, actions are taken, and those actions provide some context to the LLM. Then the most important other component is the planning, which implicitly is nothing but a reasoning, which has the capability of breaking down complex queries into simpler steps and execute in a sequential or in a parallel way. So that's what to constitute the agent. There is a fifth thing, which is the persona. Now, it has been observed that if agents play a specific role, their performance is much better compared to a generic agent. And that's where the persona part comes into picture, where we define a specific persona of an agent. So let's consider an example where I want to create an autonomous system where it writes a blog. So in writing a blog, an agent persona could be is a researcher, or another persona could be is content writing. So that's what a persona of an agent is meant. So with this as a introduction of agents, uh, let's see an example where we can use agents. So in our previous doc QA example, uh, we replaced the LLM with an agent. Now with this we get an extra capability that the agent can interact with internal databases and it can reason over the data. So let's say a user gives a query uh, uh, which is somewhat similar to what previous query was, that what does Talentica do? But at the same time, it also asks that who is the CTO of Talentica. So given that it's a multi-query user query, it will break down that query into two parts and then answer individually using the reasoning engine of the agent. So that's where the agents add the additional power to the overall system and be able to answer complex queries. Uh, Let me have a side mention about reasoning, given that like in a recent buzz about DeepSeek R1 model, uh, all these models, whether it is DeepSeek R1 model or OpenAI O1 models, they are generally referred as large reasoning models. Uh, Large reasoning models are nothing but LLMs with reasoning. The way these reasoning capabilities are introduced in them is through a reasoning mechanism, which is chain of thought reasoning, which is nothing but breaking down a complex task into simple steps and then executing each of the steps either parallelly or sequentially. uh, like large reasoning models, they have a limitation that we get reasoning capability, which is what defined by that particular vendor. A vendor could be OpenAI or even Azure Microsoft. Uh, However, if we talk about agentic reasoning, we have a capability to choose any of the reasonings, whether it is chain of thought reasoning or it is tree of thought, where instead of chain of thought, which is like a sequential kind of thoughts, we have a hierarchy of thoughts forming a tree. Um, Apart from that, it also gives us the flexibility to custom define reasoning systems, which is particularly required in case of research. So given that, in practice, what we have observed that a combination of both gives much better results, which means that we use both LRM reasoning as well as agentic reasoning. So, with that as the understanding of the agent, let's see how's the adoption across industries. So, there is a survey that was run by LangChain, which is again a framework provider for agents, and they asked two simple questions: uh, whether you have any agents in production, or whether you are planning to have agents in production. So, for the first query, it almost 50% of the organizations uh, answered yes, which means that they have agents in production. Whereas for the second question, it was about roughly about 75% of the organization which are planning to have agents in their production. So that's what the power of agents is. And in fact, a recent trend survey by Gartner says that one of the agentic AI is one of the top trends in 2025. So that's what the popularity of agents would be. So with that, let me also have one more poll, which is again ask that what is your expectation from multi-agent system? Again, I'll take a pause and we'll wait for your responses. Okay, continuing next. Let's see why we require agents when multi-agents when agents themselves can do a good job and handle complex queries. So, a- a- as I mentioned, that agents work well when they do a role playing. So, when we use general purpose agents, um, they have a problem when we have complex queries, or when the system evolves into a complex system, and that's where agents, general purpose agents, starts hallucinate and also start confused. In fact, as the complexity of the problem increases, the agent tool space will become more big, large, and again, there also it becomes adds more complexity into the system. Um, uh, Role playing is something that gives us agents its performance, and that's where agents needs to be dedicated agents doing certain specific tasks. Uh, with the introduction of multi-agents, we also have the capability of collaborating between agents, and that sets the context much better compared to having a single agent. So with this, uh, it sets up a need for having multi-agents, and be able to solve complex problems. Again, let's consider the similar example that we have discussed in the previous slides of doc QA. Now, in this case, instead of having a single agent, we have three agents: a query transform agent, a retrieval agent, and an output formatting agent. Uh, in a chatbot scenarios, we have a lot of interaction with the system, and user usually asks questions which has been answered in the previous interactions, but in a different way. So agent, the whole system needs to understand that what is the context from the previous chatbot history, and then transform the query accordingly. So that's where we require an agent to be able to transform those query by getting context from previous interaction. A retrieval agent is useful when we have different sources of data, and whenever a query comes, the retrieval agent needs to decide that which sources of data are useful for answering the user query. In case of output agent, uh, output agent needs to decide that whether my query uh, needs to have an output in a table form, or it needs to have an output in a simple text form, or it needs to be some sort of a plot. So that's where the output agent decides on that. So now we can clearly see that where the multi agents come into picture, that it enhances the overall system capabilities. Uh, so now, as soon as we introduce multiple agents, um some thoughts come that how these agents collaborate among themselves. So there are different ways. One is like the agents can collaborate either in a sequential way, or they start debating and then come to a consensus, which is what the left side structures talk about. There could be other ways, like we have a leader agent which delegates tasks to the subordinate agents, and then they interact among themselves, which is what the hierarchical structure is. In based on our experience, what we have observed, that it is a combination of both which actually works well, which is like a part of it is sequential, and another part is in a delegate manner. So, talking about some of the frameworks that multi-agents have. Uh, one of the common agent framework provided by Microsoft is Autogen. Their whole theme is conversational. So, uh, uh, agents interact in a conversational way, and achieve a certain task. Whereas the Creo AI, it is more of a role-playing kind of framework there, where each of the agents are assigned a role, and they collaborate in a sequential or a hierarchical way. Uh, Lang Graph also provides a framework which is in a different way compared to Microsoft and Creo AI, where it assumes a graph, and each of the nodes can be agents. Swarm is actually provided by OpenAI as a agent framework, but it is mostly from the educational perspective. So let's consider a use case of from the e-commerce space, where we have a workflow. and a user is interacting with the chatbot and asking questions. Let's say user wants to order a particular product, and and there is a triage agent which tries to get certain requirements from the user before it forwards that query to the sales agent. Now, sales agent looks into the inventory and looks other details before it actually confirms the order and pays the order and confirm it to the user. In another scenario, a user wants to basically seek a refund for a particular product. Again, there is a refund agent which looks into the details which product needs to be refunded, and once it checks all the details, then it confirms the refund to the user. So this is a simple case of workflow management using multi-agent. There are other use cases can be there for the workflow management, like loan application processing, campaign management, and even in the customer service. Uh, Microsoft has shown that using multi-agent, they can actually synthesize a good quality data by iteratively processing over the generated data. And we have already seen a use case of multi-agent rack system where we have different agents doing a specific task, like a retrieval agent or a semantic caching agent or even the output generation agent. So with this as the use case about multi-agents and how the overall agents work, I now hand over to Seema, who will talk about how they have leveraged the power of multi-agent in their product. Seema?
All right. Thank you, Abhishek. Hello, everyone. I'm Seema Menon. I'm the co-founder of Maestro.ai. I've been a product and engineering leader for 20 plus years now, driving innovation and launching impactful solutions in technology companies, both startup and enterprise environments. Excited to be here today with you all to talk about agentic AI and multi-agent systems. Oh, sorry, give me 1 second here. Okay, so for some background about Maestro, we are transforming customer outreach and engagement workflows for the marketing and sales teams, driving increased efficiency, productivity, and higher ROI. Now, over my career, I've firsthand experienced how technology can simplify complexity and unlock new opportunities. And Maestro is the culmination of those experiences. So today, I will walk you through our approach to solving key challenges in digital marketing with agentic AI systems, the tangible benefits they bring, and the lessons we learned while building a production-ready multi-agent platform. Okay, so let's start by taking a look at what it actually takes to plan and launch a marketing campaign today. So this process typically involves a few key steps. Planning based on your business objectives, deciding on the campaign goals, the target audience, the channels, duration, KPIs, and so on. So planning by itself is a very involved process that is time consuming and also research intensive, as it takes into account both real-time information like market trends, competitive landscape, as well as historic campaign data, and then customer insights and feedback. Then messaging and creatives. Now, designing engaging emails and ad copies with images, videos that resonates with the target audience, resulting in higher conversion rates. Then comes the setup. Now, depending on the channels, setting up and configuring across all the different tools. So segmenting and importing the right customer list, setting up sequences, and kicking off the campaign. So once the campaign is off and running, monitoring performance across, say, multiple dashboards and trying to piece together meaningful insights and figuring out what actions to take um, based on the insights. So finally, optimizing, making the necessary adjustments, running A/B tests if you need to, and then refining the campaign for better results. So as you can see, despite the explosion of marketing automation tools in the market today, most of these steps still require manual effort and handoffs. So it can take weeks, sometimes even months, to fully execute a campaign. So, and by the time it's up and running, you still might not have a clear picture of your return on investment. Even worse, after the campaign runs its course, there is a good chance that you may end up not meeting your target KPIs. And then, not to mention, the automation tools themselves come with rigid workflows and steep learning curves. Now, this problem is especially challenging for small and medium businesses. Unlike large enterprises with dedicated teams for, say, marketing ops, data analysis, creative development, SMBs are often constrained by limited time, budgets, and expertise. So many SMBs end up turning to marketing agencies for help, but that comes with its own set of challenges, bloated costs, and unknown ROI. The agencies get paid for the work they do and not the outcome, right? So the challenge is running effective marketing campaigns take time, involves a ton of manual steps, skilled workers, and is expensive for businesses who need quick turnarounds and measurable results at affordable costs, of course. So we are addressing this problem with an AI agent who is your on-demand campaign manager, if you will. Since I'm talking to a technical audience here, as you probably already guessed, the platform itself is built with multiple specialized agents who are experts in their own areas, working together, making decisions, executing actions, all towards the ultimate goal of meeting and exceeding campaign KPIs. So I am oversimplifying this, but just to give you an idea, at a high level, we can group them into three key, areas of expertise. Each one has one or more agents. They can be hierarchical, sequential, depending on the workflows. And each one of these agents have connected tools. And in our case, these are data sources. These are internal data systems of record, like the CRM systems, and the activation channels, like all your email and social media channels and any other tools that you may be using. Now, along with this, there is business-specific context that is stored in vector database. So these agents work collaboratively, leveraging data and the knowledge to then deliver a better outcome. So what this does is it results in a system that is not just automated, but intelligent and adaptive. Okay. Now, one of the design considerations we needed to make was the balance between autonomy and human oversight. So while the agents handle the heavy lifting, we still wanted to make sure that marketers retained control of where it mattered the most. So we introduced human in the loop for approvals as opposed to being fully autonomous. So a couple of key points in the workflow. One is ensuring that the strategy aligns with the overarching business objectives. So the second is the final approval before the campaign gets launched. So this model helped ensure that while AI amplified human creativity and decision making, rather than replacing it. So the way we built it, we made this configurable. So when we are truly ready for this to be fully autonomous, that is when we know that the system can be fully trusted and is reliable and is doing all the right things, we can just flip the switch and it becomes autonomous. Okay, so what this allowed us to do is deliver measurable business value in terms of efficiency, ROI, and scalability. So the campaigns are executed faster with reduced operational bottlenecks, and then enhanced targeting and real-time optimization directly improved ROI. And then businesses can handle, or this allowed the businesses to handle growing volumes of campaigns without needing to proportionally increase resources. So scalability. So we streamlined the end-to-end workflow with 80 to 90% reduction in campaign turnaround time. And with continuous monitoring and optimization, we were able to ensure that the campaign KPIs were either met or exceeded. And finally, some insights or lessons learned as part of building a production-ready application. So first and foremost, the performance of an agent, as you all know, heavily depends on the foundational LLM that it's built on. And what a multi-agent system allows us is the flexibility to use a different foundational model for each agent. For example, in our case, the capability of a strategist agent, a campaign strategist, is very different from the creativity aspect of the content and messaging agent. So we were able to experiment with different foundational models to find the best for each. And it also helped, as during development, reduce cost and ensure that overall we are cost optimized. The second one, reliable infrastructure and integrations. It goes without saying that this plays a huge role in the agent's ability to operate seamlessly. The agentic architecture itself allows for retrials and recovery when things fail, but ultimately you need to ensure that it works as expected and is reliable. So as you can imagine, is an engineering problem that takes time and effort. The third one, user experience. As with any application, a simple and intuitive UI is extremely critical. And as a product leader, I have to say that this is a very interesting problem. And we have traditionally built SaaS applications as a tool to be used by an operator to get the job done. Now, there is a fundamental, a paradigm shift here where an agent is an operator who uses the available tools to then produce the work output. And the output is completed work. So the user experience flow needs to align with this expectation for the overall user experience to become intuitive for the end users. Finally, robust testing and validation, ensuring consistent and reliable performance requires rigorous testing and iterations. And we need to ensure that the agents operate within certain guardrails. So, in conclusion, the pace at which the innovation is happening around the agentic AI frameworks, tools, and the supporting technologies is just remarkable. And I have to say that I'm truly excited about its potential. So thank you for joining me, and I'll be happy to address any comments or questions. Let me now hand it back to Abhishek.
Yeah, thanks, Seema, for that insight about the product. Let me now also talk about what are different production challenges we faced while working with multi-agents. One of the challenge is like as the complex system grows, the interaction between the agents becomes more complex. And a simple way to handle is to choose a right architecture, multi-agent architecture, starting with very simple sequential kind of interaction, and then identifying where all places we need to have a different kind of interaction between the agents. Other is the human in the loop, which already Seema talked about. But as a side mention that these human in the loops needs to be specifically decided where exactly needs to be placed and how it needs to be handled. A state space based approach can be a good handy way of handling human in the loop, which nowadays are also being provided by most of the multi-agent frameworks. We already talked about LLM hallucination, especially when the LLM is not aware about any information. And we have also seen that even with simple scenarios, it tries to hallucinate. And what we have observed is that if we put a structure to an output, either in the form of JSON or YAML, then its performance is much better compared to having a no structure in the output. Last but not the least, due to multiple interaction between agents and even agent interacting multiple times with LLMs, usually the multi-agent systems and even a single agent system is slow, so they cannot be used in real-time scenarios. However, to some extent, this response time can be reduced by using open source models and using appropriate size GPU to be able to get a response in a reasonable amount of time. So with that, let me also talk about some of the predictions that we think will be there for in near future for multi-agents. As the LLM grows, the power of multi-agent will grow, and they'll be able to perform in a much better way. Like we have app stores, we'll also have a marketplace for agents. Each of the agents will be having a dedicated predefined role to play and has been trained on a specific task. There's a growing need for agents to interact with different sources of data, whether it is image, audio, video, textual, and that's where need for multimodal agents will grow. Last but not the least, as Seema already mentioned about that autonomous agents, for simple to medium problems, the autonomous agents will grow, and over the period, they'll be able to handle more complex tasks. With that, we are now ready for answer the questions with which any one of you have.
Excellent. Thank you both for really informative presentation. I've asked our attendees to start posting their questions into the chat. And I see we're already getting some, so let's jump right into it. One of the attendees is asking, should we use multi-agent systems for any workflow automation?
Well, yeah, so need not be, because if your workflow system is completely deterministic, then it doesn't require any intelligence. And in those cases, you don't require a multi-agent system. Wherever there's a need for intelligent interaction with the end user, that's where we require multi-agent system.
Excellent. Okay, Don asks, does the chain of thought slow down real-time agents? Is that part of what you meant by too slow for real-time?
Well, it's only one factor that the agents get slowed down because of chain of thought, but there are many other reasons, like agents interact with databases, get the data, create a relevant context. They interact with LLM multiple times to get the right answer by doing self-consistency thing. So that's where, like, there are multiple factors which adds to the slowness of the agents.
Okay, very good. So the next question would be, when should an organization invest in multi-agent systems?
Well, so it depends on like what ROI you want from the system. So first analysis needs to be done that whether my multi-agent system be able to give me a time benefit. Let's say a particular manual job takes 1 week to complete. Whether my multi-agent system will be able to reduce that in few hours. So if that ROI is there, then that's where we can think of using multi-agent system.
And the lack of just to add to that, I think taking a look at the efficiency aspect of it, right, and the time it takes, and the amount of people or resources, and then assessing and handoffs, and so there are a lot of different factors that you can consider before you say, okay, this is something that an agentic system can do better and do faster, because you can see that there are multiple input sources of data or information that needs to be consumed to then make an informed decision and then execute certain things. So those would be some of the considerations.
Mm-hmm. Excellent. Okay, along those lines, somebody asks, what are the underlying foundation models used in Maestro to support the different agents? And what should one consider when choosing the foundation models?
Well, for the Maestro application, we're using the Crew.AI framework, and so we started building this early last year. So this is where the technology, the frameworks are evolving super fast, and when we started, they were in their early stages. So when we compared the various frameworks and the support, the community support, that was the other aspect. And, looking at all of these, figuring out what is something that is, say, almost ready, production ready. And so those were some of the factors that influenced the framework decision. And then the models, we started with, the OpenAI models and GPT 4.0, and then used 4.0 mini. And 0.1, is actually really good. And we also used Claude for certain parts just to test. Now, some of the considerations, and one is like the ability. Now, each of these models do well in certain things. Like, what I have found, this is just, personal opinion. Claude does a really good job with writing code and, certain things like that. Whereas I found that GPT-4o did a great job with the content and the creatives that we were trying to do with our content creator agent. So those were some considerations. Then there was always the cost factor. So 4.0 mini came in very cheap relative to 4.0. And so switching a bunch of agents to use 4.0 mini helped with the overall cost optimization since we were paying for OpenAI tokens. Now, why OpenAI? The truth be told, it's we did get free credits as a startup, and so that is what got us started with OpenAI.
So let me also add to Seema, and this is not specific to Maestro, but in general, any foundation models. The choice is also between whether to use managed foundation models or to use open source foundation models. And that choice comes again, like one of the factors that Seema already talked about is the cost. Usually the managed foundation models, especially when you have less traffic, they come out to be more efficient in terms of cost. As when the traffic into the system increases, which means that we make use of more of foundation models, there is a break-even point after which open source model starts come more cheaper because you host your own GPU and the cost of using those LLMs then balances with the GPU cost. So this is another side thing about foundation models in terms of choice of foundation models.
Excellent. Okay, I would remind everybody that we're close to coming up on the hour. So if you have any other questions, please post them now. And as I said earlier, we'll get to as many as time allows. But getting back to the questions now, Geetha wants to know, can you elaborate on the human in the loop mentioned as a production-ready challenge and what was meant by that?
So like one of the challenges that deciding where to provide the human in the loop. Like there can be multiple places where you can have like validating the data, whether the data that is generated by LLM, whether that data is right or not. But there are some other systems where you don't require that kind of validation. Like through interaction with the user, you can actually come into the right answer. So it totally depends on the use case, and that's where deciding the right set of human, because like if we have too many human in the loop, then like it's effectively a person doing the whole thing. Then there is no need of multi-agent. So it should be a minimal human in the loop, but at the same time it should solve the purpose.
Mm-hmm. Okay, another question from Michelle wants to know what standard is adopted to allow agents to interact with one another? Kind of foundational.
Well, that's a research thing. People are thinking to standardize the collaboration between agents because in future we'll have heterogeneous agents interacting, like agent created by one organization and agent created by another organization, and they are interacting. So it is still a research topic, and there are discussions to standardize the interaction. As such, in the current scenario, there are no standardized interactions that are set by any of these framework providers.
Mm-hmm. So within the framework itself, to add to that, like, say through AI, all of that, the interaction is handled by them. It's, so as you're building applications, much of this is, already done. And much of it, I have to also say, is natural language based.
Mm-hmm. Okay, we have a question from Philippe, who wants to know, what is the best framework recommended today? And in parentheses, he put LangChain, LangGraph. What I know it's, there's so many of it. It's a very broad answer, but if you can recommend anything, I think you'd want to know.
Yeah, so like as David mentioned, that it's a big ocean. Like there are almost every month or every 2 months there is a new framework that is coming about for multi agents. So, however, like just to answer to that question, that if we talk about like among those four frameworks that we have tried, it depends on the use case. Autogen kind of framework is more suitable for conversational AI scenarios, whereas Creo AI it is more focused towards the role playing kind of thing, and the line graph framework is gives us not only the graph kind of thing, but it also provides us more granular uh, thing where you can decide uh, how the graph should look like and how the agent should interact. So all that flexibility is provided by line graph. And Swarm, as I mentioned, it is just for educational purpose. So you can create quick agents using Swarm, but again, like it's not production ready.
Gotcha. Okay, looks like we have time for about one more. And this is kind of an interesting question. David wants to know, what could be purchased from your firms? So what are your offerings? Let's start with you, Mike.
Okay. We are providing, like, we are data scientists, so we are capable of creating products out of multi-agents. How the product, you can use multi-agents in the product, apart from like other data science things. So that's what our offering. Seema, what about your?
So we're building, marketing, like I said, your agents that marketing and sales teams can use. So we are targeting SMB, small and medium businesses who need help with their marketing in campaign management.
Good. All right, I'm going to slip one more in here before I ask you for final thoughts. So the question is, how do you go about testing the solution before commercializing the solution?
So it is a tough one. I touched on this as one of the learnings too. So there are all aspects of testing and validating a traditional, production ready system that is hosted on the cloud and is a SaaS-like solution. So everything from infrastructure to running functional testing, all of that has to be done. Now, where this gets complicated is the agentic workflow, making sure that the agents are doing the right things, are reliable, the output is consistent. And that requires simulation, if you will. So that is where I think either by way of scripts or tools. Now, I've seen that there are up and coming tools, although we're still only planning to use them. But we did a lot of it in house to make sure that we were able to sort of simulate some of the scenarios, and especially where there are the natural language input touch points, to make sure that the agent behavior would be consistent and the output and the outcome would be consistent. So a lot of effort. And if you have qualitative aspects, like say the messaging, right, the email copywriting, so in those aspects, making sure that you have some sort of feedback mechanism where, when you're testing, you can provide feedback to the agent, which can then be used to make the agent learn and get better. So these are some of the methods we use to ensure that we tested the solution before productizing.
Yeah, and just to add to Seema, that like there is no standard framework for testing multi-agent systems. However, there are ways to test the system. One is like a straightforward way of manually looking into the output, but we also have LLMs dedicated for judging the output quality, which is like LLM behaving as a judge, and LLM itself judges that whether this particular output is relevant to what the user has actually asked. So these are the different other ways to test the multi-agent systems and see whether your overall system is working as expected.
Mhm. Okay, so we have about a minute left, so I would throw it out to you guys for one final takeaway. If there's one thing that our attendees need to know, maybe you could shed a little 30-second summary.
Okay, so from my side, it is like agents will be the next big thing, and multi-agent is a natural outcome of agents because we do require interaction between the agents, given that they are will behave as in a role-playing mode.
Okay.
Seema, over to you.
Yeah, and I just would add that the whole the innovation and the pace that I talked about is just tremendous, and things are happening every single day, and the frameworks are evolving and tools are getting developed, and so just staying on top of it itself is critically important, and the agents themselves are getting better and better every single day, and then not to mention the underlying foundation models and the capabilities that they are delivering is also every single day you hear about how they're making great leaps and bounds. So all in all, it's an exciting time to be, building these systems.
Absolutely, no question about that. All right, I'd like to thank Abhishek and Seema for today's presentation, as well as Talentica for sponsoring the program. And of course, thanks to all of you for joining us today. We hope you got the information that you need about LLMs and can move forward with that. So until next time, I'm Dave Rubenstein. So long for now.
Thank you.
Thank you.
Bye-bye.
Bye.